If the lengths of the three sides of a triangle are given, or if two sides and the included angle are given, you can use the law of cosines to find unknowns. Let's first understand the law of cosines. Let's denote the length of the base of the yellow right triangle as x. Using the Pythagorean theorem, we can express it as follows. Similarly, for the blue right triangle, the length of the base is b minus x. And we can express it as. Now, we can manipulate the first equation and substitute it into the second one. After simplifying, we eliminate the x squared term on the right side. Next, considering the yellow triangle, if we use the cosine ratio, we have cosine A equals x over c. In other words, x equals c times cosine A. Substitute this into our derived equation. This completes the derivation of the law of cosines. Now, let's solve a problem where the three sides are given. Substituting the given numbers into our cosine law equation, we get. Calculating this expression, we find. Since we need to find angle A, we move the term containing cosine A from the right side to the left. After dividing by the constant term and performing the calculations, we obtain a decimal value. Using the inverse cosine function allows us to determine the magnitude of angle A. Measure of angle A is about 21.787 degrees. Now, let's rearrange the law of cosines into an equation for b to determine the magnitude of angle B, substituting the given numbers. After simplifying, we move the term containing cosine B from the right side to the left to solve for angle B. After dividing by the constant term, using the inverse cosine function allows us to find the magnitude of angle B. Measure of angle B is 120 degrees. The remaining angle C can be found by subtracting angles A and B from 180 degrees. Therefore, we have determined the magnitudes of all three angles we sought. In this case, we are given the lengths of two sides and the measure of the included angle. Since the given angle is A, we can use the law of cosines to formulate an equation for side A, substituting the given numbers. And since the right side consists entirely of constant terms, you can use a calculator to perform the calculations. Taking the square root of both sides allows us to determine the value of A. Length A is about 5.176. Let's take a moment to consider. To determine the magnitudes of the remaining two angles, both the law of sines and the law of cosines can be applied. However, generally, using the law of cosines is more advantageous. This is because the inverse sine function provides angles without distinguishing between acute and obtuse angles when given a sine value. On the other hand, the inverse cosine will distinguish obtuse angles from acute angle. Remember this. Now, let's rearrange the law of cosines into an equation for side B, to find the magnitude of angle B, substituting the given numbers. After simplifying, we move the term containing cosine B from the right side to the left to solve for angle B. After simplifying and dividing by the constant term, using the inverse cosine function allows us to find the magnitude of angle B. Angle C can be found by subtracting the magnitudes of the remaining two angles from 180 degrees. Therefore, we have successfully found the magnitudes of the two angles and the length of one side we were seeking. See you next time.